On this road, safety belts need to be unfastened. No joke. It's so you can jump out of the car if necessary. Because underneath, there is water that runs several meters deep. This is a frozen sea. And this is what winters in parts of the northern hemisphere could permanently look like in 150 years. It has to do with the movement of water deep in the ocean, a system called AMOC.
So a collapse in the AMOC would in short be catastrophic.
The planet is heating up at an unprecedented rate. Let's get into why it's also so cold. Usually, the waves of the Baltic Sea crash here. We're in eastern Estonia, where in early February 2026, ferries could no longer ply. 2 islands off the coast were connected via this ice road. It had already cracked at some points, but the locals driving here aren't really bothered.
Ei, mis siin ikka karta, kui ta on ametlikult avatud, siis ei karda. Oma pead võib-olla ei tahaks just minna.
No, äkki närv on sees, aga küll hakkama saab.
Täna vast esimest korda. Mugav on ju jäätee.
Ei karda, et ohtlik või kuidagi.
Jääteed küll pole põhjust karta.
Meanwhile, further south, this was Germany. In the capital Berlin, frozen lakes and canals turned the city into a skating rink with sub-zero temperatures for weeks. This happened because of winds up in the sky.
Meteorologists have confirmed that the cause of this extreme weather is a combination of a weakening and a collapse of the stratospheric polar vortex.
That's basically this blue and purple mass of cold air in the Arctic. For many reasons, including that the Arctic is warming, it sometimes becomes unstable and spills south, sending freezing temperatures downwards in short bursts.
Yeah, so this is your classic difference between climate and weather, where weather is what happens over a period of hours, days, weeks, and climate is just the average of this, so what we might expect.
Okay, so this cold winter in Estonia and Berlin has more to do with weather and the behavior of the vortex, which we might see more often as the Arctic warms. But other climate models that took a look at a different aspect predict that these extreme weathers could become even more frequent and way more intense. And this is down to our oceans, where water flows, swirls and mixes, and where currents travel across the globe. The system of currents we're talking about is called the Atlantic Meridional Overturning Circulation, short AMOC. It's what gives Europe its mild, stable climate and impacts the monsoons in India and China. Think of it like a heat superhighway. Warm water flows from the tropics near Brazil and the Caribbean Sea up to Europe and further on to Greenland. Here it cools, sinks and finally flows back to the south. What moves the water is this.
So maybe you've seen those pictures that people are just floating on the Dead Sea, because the salinity concentration is very high.
Lots of salt means water becomes dense and heavy and sinks. This typically happens near Greenland, where the water is extremely salty and cold, perfect for sinking. That's how it should be. But as our planet heats up, it's causing Greenland's ice sheets to melt. This means more fresh water is pouring into the ocean. And warmer, fresher water masses mean
they are lighter, so they don't want to sink.
The whole system slows down or eventually collapses, and the heat is trapped in the tropics. Less heat is transported to the north. The Hollywood movie The Day After Tomorrow has a pretty grim take on what this would mean.
Mr. Vice President, if we don't act now, it's going to be too late.
Superstorms obliterate New York here. It's exaggerated, as Hollywood blockbusters are, but the underlying message of the movie is not wrong.
A collapse in the AMOC would in short be catastrophic. Because all this heat is no longer being transported north, it remains more in the tropical regions, and also we see a warming of the southern hemisphere.
A change in the system of ocean currents then basically affects a ton of key weather patterns. One study predicts almost 50% more monsoon rain in the Amazon, 20% less in India, and a rainy season that is 1 month shorter. In Southeast Asia, more than 100 million farmers depend on these monsoon rains for crop yields, so their future would be uncertain. And in Europe?
Regional cooling of up to minus 20 degrees, so this would be off the coast of Norway, for example. And then for continental Europe, we would also expect a dramatic drop in yearly average temperature, with negative temperatures of up to, for example, minus 10 degrees in winter.
Look at this map. It shows average temperatures if the planet warms by 2 degrees and the AMOC collapses. For some northern regions, it could be kind of like the opposite of global warming on steroids. Copenhagen, Edinburgh, Riga, parts of eastern Canada would be covered in sea ice even in March. You could then literally walk from the UK to Norway.
You can actually see that the whole world is warming, except this very small part in northwestern Europe where you see it is actually cooling rather than warming. So that means that really northwestern Europe becomes like an outcast compared to other parts of the world.
A scary prospect, but how certain are we about it?
Well, so this is a very big debate within the AMOC community. So this is clearly not settled. So if you only look at direct observations, we see a gradual decline of the AMOC.
The data shows it is weakening, but it's not super obvious, and scientists have only measured its speed for 20 years.
The time series is simply too short. But if you look at the weakening that we do see, this aligns with the amount of weakening we see in climate models over the same period.
So, is this a preview of the future?
That is something very hard to say because it also depends on the amount of global warming. So, like the cooling effect of the AMOC, that can be cancelled if the climate continues to warm at a very rapid pace that we see nowadays. But if the warming is not that large, then we could see much colder winters over Europe.
Science is starting to document some effects of a weaker AMOC. Though a potential collapse is only predicted post-2100. If all this feels hypothetical, it's because it is to some extent.
A colleague of mine likes to put it this way, is that even if the risk of an AMOC collapse in this century is 1%, would you get on a plane if there was a 1% chance that it would crash? I mean, I think most people would say no. These are very real dangers that we have to address as quickly as possible because the consequences, if we don't, are almost unthinkable.
The good news is we can avoid it by ending fossil fuel use and thereby slowing down global warming. So that ice roads like these remain what they are today. Rare snapshots of an exceptional winter.